meters length and 0.6 meters dia is embedded in a stiff clay which has undrained unit cohesion of 110 kilonewton per meter square. The adhesion factor is 0.5. The net ultimate pull-out uplift load for the pile is. So what he said? He said a circular pile of length 12 meters, right? So this is 12 meters. This is 0.6 meters. That is 12 meters. This is 0.6 meters dia is embedded in a stiff clay which has undrained cohesion. So Cu is given as 110 kilonewton per meter square. The adhesion factor alpha is also given to you as 0.5. So the ultimate pullout, if it is given that the circular pile is embedded in the stiff clay, you know, the strength is generally given by the circumference. That is, if you see here, this would be pi dl multiplied with alpha multiplied with Cu. So this is what generally you will get the skin friction resistance. So the pull-out resistance would be skin friction resistance. There will not be any end resistance. There will be only skin friction resistance over here. So pi d is given to you as 0.6, L is given to you as 12 meters, alpha is given to you as 0.5 and Cu is given to you as 110 kilonewton per meter square. If you substitute all these things, you will get the pull-out capacity as 1244.7. He said 1 decimal point kilonewton per meter kilonewtons. 1244.7 kilonewtons. He has pull-out load. So this pull-out load is given as 1244.7 kilonewtons. These type of problems you have to properly read what type of soil it is and what are the strengths that you are going to get. If it is embedded in the sand, there will be end bearing resistance. If it is for the clay, there will be skin friction resistance, and sometimes in silt type of soils you will see both skin friction resistance and end bearing resistance. So based on that, keep on applying the formulas and then you will get the answer, and for this is how you will solve the question. Thank you.